Good morning, it's Matt here. So this is our Hyundai Ioniq Electric. It's a 28 kilowatt hour model. This is a 2017 car and it's now done just under 102,000 miles. And in this video I'm going to change the coolant. I've been asked about coolant change quite a few times in my other videos and I've never actually done one of these before. That's because most of these cars aren't old enough yet to require a coolant change. Well, the early ones are now getting to the age where, yeah, it probably needs doing. So this car is now 5.5 years, actually no, April. So yeah, it's coming up to nearly 6 years old actually, 102,000 miles. So it's about time the coolant was changed. So this could be quite a long video, so I'm going to put chapters down below at the bottom of the screen on YouTube that you can jump to various sections if you want. So first off, the service schedule. When should you change that coolant? Well, that's what I've been struggling to find out. You can get the service schedules from the States and Canada on these cars, and they're all the same cars. They're all built in Korea. On those, they say the coolant needs changing at 120,000 miles or 5.5 years. And then once you've done that, I'm just checking my notes here, they then say you change it every 2 years and 20,000 miles, which makes absolutely no sense to me, when coolant has a life of 5 years minimum, 8 years on some of the new hybrid stuff. So why you got to change it every 2 years, I don't know. But in the UK, and looking through the manual, I can't see any reference to when the coolant has got to be changed. So if you know, drop it in the comments below. But anyway, coolant, typically the type of coolant this car uses has a life of 5 years. So it's got to be changed about every 5 years or so. So next, the type of coolant you've got to buy. Right, this is a big one. I've been doing lots of research on this because when you make YouTube videos and put this information up online, you've got to get your facts right and you will soon get slammed if you don't. So I thought I'll do a bit of research and find out the proper coolant that you've got to put in here. I've just gone down a rabbit hole of coolants. The range of coolants you can now get for modern cars is just vast and it's all very confusing. And I've spent hours and hours on the internet looking up coolant types, what they all do. But anyway, what I'm going to do is go through that sort of process just so it'll help you if you're going down that same rabbit hole, and all the things I've found and my final conclusion of what has actually got to go in here. So first, let's refer to the user manual, which is always the best place. Firstly, the antifreeze and water mix. So let's start with the basics. You've got coolant and you've got antifreeze. Antifreeze is the concentrated stuff that you add distilled water to make coolant. So you can either buy antifreeze and then add your own distilled water to it and get your mix right for your region, or you can just buy ready mix stuff and that's then called coolant, and that's generally a 50-50 mix. For the UK, I think we need a 40-60 mix is the best sort of mix. So 40% antifreeze, 60% water. And that gets us down to minus 25 degrees C, and it's never that cold in the UK. A 50-50 mix gets us down to minus 35, so that's a bit excessive for the UK climate. But if you're going to buy coolant, that's already pre-mixed at 50-50. So it's going to be more than adequate for the temperatures we get in the UK. And that information is on page 712 in the manual. Next we go to section 8.6, which is specifications and the type of coolant and the quantity. And notice on the UK manual they have put a sticker over the chart here. And they've also done the same on the air conditioning. So I would imagine this manual is for the American market, possibly, and then the UK and Europe versions have a sticker over the top changing the information. But anyway, we're in UK here, so that's what we're going to concentrate on. All the UK cars have a heat pump. So the capacity of the system is with a heat pump 4.6 to 4.7 litres, so that's how much coolant you're going to have to buy. And the coolant, a mixture of antifreeze and water, as I said, and the antifreeze is a phosphate based ethylene glycol coolant for aluminium radiator. So that's where the fun began, trying to work out what actually is a phosphate based coolant, because basically that stuff isn't sold in the UK. So I think this is a very sort of generic term Hyundai use because all their petrol vehicles are the same, and over in Asia they favour phosphate based coolants, whereas things have moved on in Europe and particularly in the UK. You just cannot buy phosphate based coolants. They've all gone on to silicate based, which is an alternative. So I then started researching, well, can you use that? What's the differences? And Jesus, it is a minefield. There are just so many different types of coolant available now, and trying to work out whether you can or can't use a particular coolant is very difficult. And what I found is the information out there online really does vary, and some completely contradicts others, and you just don't know where you're going with it. And I've even gone to the manufacturer's website, even BSF Chemicals, who make the actual antifreeze mix, which is then sold to all the coolant manufacturers, and even then I found information conflicting each other, and sometimes it said it had phosphate, sometimes it didn't, and it was just very, very difficult. And I've got specs for the same product and they contradicted each other. So there's a lot of misinformation out there, repeated information, and errors get repeated. And I've actually found the same thing, funny enough, with tumble dryers. I recently bought a tumble dryer, and I wanted specifically a 24-hour timer on it so we could put the tumble dryer on during the cheap rate nighttime tariff. And after a lot of research and only using the manufacturer's spec sheets, I bought a Candy tumble dryer because it said it had a 24-hour timer and it had other particular features that we wanted, like reverse action and things. And when it came, it had a 3, 6 and 9 hour timer, 9 hours maximum, didn't have a 24-hour timer, and the manufacturer's spreadsheet was wrong. And I spoke to the manufacturer and they just didn't want to know. They thought I was wrong, and we ended up sending the machine back. And that misinformation got repeated through suppliers, and when manufacturers get it wrong, it just gets repeated, and it's really difficult to know what to trust out there. Someone makes a mistake on a spec sheet, it doesn't get picked up, and it just gets replicated. And I've very much found the same with coolant. There was different spec sheets for the same product with different information on. And I think it's just a case of the times. People don't really take care in their job, make a simple mistake, doesn't get checked, and it just gets replicated online because information is shared so easily nowadays. So a good source of information, and where I really started at looking at different coolant types, was the Coma brand, or Coma brand, I don't know how you say it, but that's what we get in the UK, that Halford sell, the motor factors all sell, and they do all the different types. They do lots of different types of coolant, and they're using BASF chemicals from Germany. So I was on their website looking at their specs as well. They do lots of different types: G30, G40, G48, G05, many different types of coolant, and it was quite clear with them what each one did. I even spoke to the manufacturer themselves, more chemicals or more oils, I can't remember what they were called, but anyway, I spoke to a very helpful guy there on the technical helpline just to confirm my findings, because actually what I thought after going into it all, what I needed for this car was, I think, a G64. Yes, G64. I'm just referring to some of my notes here, which was referred to as a phosphate stroke silica based oat antifreeze or coolant, and that seemed to be the best match for this car, keeping with that Hyundai spec in the manual. And it's quite a basic old style coolant, and quite cheap as well. Also, by chance, it's the same colour. So that's what I thought it was the right stuff. If you go on Halford's vehicle lookup thing, they say a G30, which actually is wrong. But that's the Hyundai spec antifreeze for all their combustion engine vehicles, which it would probably be absolutely fine in here. I think actually the reality is it doesn't really matter too much what coolant is in here, but I wanted to get it right, and obviously if I'm going to make this video I needed to get my facts right, so I went down this rabbit hole, as I said. So I ended up speaking to Moore themselves, and he confirmed that none of their antifreezes whatsoever have phosphates, and therefore if I wanted to match what Hyundai say, none of their products would be suitable, and they were actually planning to bring back a phosphate based one in the future, and there may be something in the future in their product line. I also asked him, well, what manufacturer does do that, and he didn't know, and sort of confirmed you're not really going to find this stuff in the UK anyway. So basically phosphate is what they use in Asia in their antifreeze, but we've in the UK have all gone down the silicate based antifreeze, which basically replaces phosphate. So whether you can use silicate based antifreeze in here, I'm not sure, but I suspect so. It's absolutely fine, but there were some references saying no, you mustn't use it because it will affect water pumps, but does that really affect a water pump on these? It's only one water pump. That's probably more for combustion engine vehicles. But the whole thing is an absolute minefield, and I can be sure that main dealers and garages do not put any effort into this. They will just have one type of antifreeze that they put across multiple models, including the EVs. EVs are nothing special. It is a bit different when you have a battery cooling system like the Ioniq 38 and the new Ioniq 5 and whatever. But when you're just cooling the motor and inverter and going through the radiator at the front here, I really don't think it matters that much. But anyway, let's continue. So when looking into the specs of antifreeze, there's lots of different specs, numbers and different technologies. There's basically an oat, which is an organic acid technology. There is an IAT, I think, which is the older stuff. There's lots of what, as I said, most of them have silicon in, so they've usually got an S in front. What we actually want for this, if you want to go by the Hyundai spec, is you need an oat, but you need a phosphate based oat, which is called a POAT, or you get a pH oat, which is the phosphate hybrid oat antifreeze. But I'll put a lot of this in the description of the video. If you want to learn more about all of this, I'll do some write-up in the video description. So that's basically what you're looking for, is a P-oat or P-HOAT antifreeze, and that is very difficult to find in the UK. I only found one supplier who did that, and that was Motul, and they do a hybrid antifreeze which is pink, and the only place that was doing that online was Demon Tweaks, and they've got it on their eBay site and you can buy it online, so I'll put a link to that in the description as well. That is the only antifreeze I could find in the UK which absolutely matched the hybrid, the Hyundai spec to go in this car. To be honest, I think it's still a complete overkill, and I think a silica based one is probably okay to go in here. But if you want to buy the exact stuff, that Motul stuff is the only stuff I could find in the UK. If you know anything different, let me know in the comments below as well. So yes, if you know of any other P-oat antifreezes in the UK, let me know, but as of January 2023 there currently isn't. So the other option is, what do Hyundai dealers fit? Rather than fit, I mean supply or install. So I spoke to Hyundai, my local parts department, and I ended up buying the fluid off them just because the whole thing was getting so ridiculously confusing. And this is what they use apparently, which is BSC1. I'll put the part number in the description below as well. This, they only did 2 litre bottles, so I bought 2 of these. I think with the VAT it was 68 quid, so it's an awful lot of money for antifreeze. It's pre-mixed as well at 50-50. But there's nowhere on here that tells you what the specs is, so it doesn't say what this is. As I said, I'm sure it doesn't really matter, and maybe I was just being too anal about getting the right type of antifreeze in here, because at the end of the day it's only going around an aluminium block and a radiator, and that's it. So as long as it's okay for aluminium, which they pretty much all are nowadays, because we've had aluminium in engines for a very long time. But it's a shame. I was hoping this would then actually say what the chemical makeup was and what spec of antifreeze it was, but it doesn't. It's just called a BSC1, and this hasn't been out that long, so I would imagine if you've had a coolant change in your Ioniq at a main dealer sort of more than a year ago, you probably haven't got this stuff in your vehicle anyway. You've got the same coolant they would put in a petrol vehicle, which I'm sure is absolutely fine, but it would have been very nice just to drill down the perfect coolant for this. But anyway, that's what I'm going to use today. I bought it from Hyundai. It's very expensive for what it is, probably a complete overkill. This is what you would generally use in a battery cooling system. Next, let's just talk quickly about the colour of your antifreeze, and a lot of people make this mistake. Even garages are making this mistake. The colour has absolutely no bearing on the type of antifreeze whatsoever. It is just a dye that gets put into it so you can identify the levels on the tank and you can see it, otherwise you wouldn't be able to see the stuff in there, and it allows you to identify leaks and things. And the colour has really no bearing on it at all, and manufacturers will change their colour because they change suppliers. So the mistake that a lot of main dealers use, because they use the one supplier, generally the manufacturer, they will say, oh, you need the blue stuff or the pink stuff, like an Ioniq 5, you got a blue, green or pink, but those can change. It is just dye, so really please do completely ignore the colour. It has no bearing on anything at all. You can buy one coolant from one manufacturer and it'll be blue. You can buy the same spec coolant from another manufacturer and it'll be pink or red or yellow. So yeah, just completely ignore the colour of the stuff. And the stuff that's in here from the factory back in 2017 is green. Not that that means anything, and what I've bought now is blue, but if I was to go and buy this in say 2 or 3 years time, Hyundai might have changed their suppliers and it then might be green or pink or red, so it has no bearing on anything whatsoever. So next, let's just talk about what this coolant does. So this is a UK spec car and these have heat pumps. There are Ioniq 28s that don't have heat pumps. I've got the instructions from the Hyundai workshop system here, which I'll also give anyone, so there'll be a link to that in the description below, but there's a little schematic here which is showing how the coolant system works, either with a heat pump or without a heat pump. But very simply, you've got a reservoir up here, you've got a radiator at the front here, and the hoses go down and they go through this motor stack. So you've got electric motor at the bottom, and then in these aluminium houses you've got your charger system, your inverter and everything, and all of this is water cooled because it all gets very hot. So this has a water pump just there, which I'll get the torch out and show you from underneath, and there's also a 3-way valve down there which diverts the water back to the chiller or through the onboard charging system. So there's obviously temperature sensors around, so it knows where to send the water. But that's it. It's a very simple system. It's just pumping around the radiator to cool it and then going around your motor stack and your obviously your electric motor at the bottom. So there's nothing complicated or special about the system, and as I said, the 28 kilowatt hours don't have battery cooling. The batteries are air cooled on these, but the newer vehicles with the 38 kilowatt hour battery, they also do have liquid battery cooling as well, but we're not going into those vehicles in this video. This is just for changing the coolant on a 28 kilowatt hour Ioniq. Next thing I'll quickly address is, can you do this yourself? Well, it is actually a very simple system, as I said, and it's just a case of getting underneath, taking the under tray off, draining the system, and there is a drain screw in the bottom corner of the radiator, so that's very easy. Take the cap off, let the system drain through, give it a flush out if you want to, and then fill it back up and bleed it. So it is very simple to do. However, it's the bleeding process which is probably going to stop you doing it yourself, because you've got to activate the water pump to bleed the system, and the water pump doesn't come on if you just start the vehicle up and put it into ready mode, so all of this is running. It doesn't activate the water pump, So there's obviously sensors in here that the water pump only kicks in when it actually all starts getting hot, and it's got to circulate the water. And you don't really want to have air bubbles in there and have hot spots. So you don't want to leave it running so long that it all gets hot before it starts circulating water, because there might be hot spots and it could cause damage. So that's also what's delayed me from doing this job myself, because I didn't know how you bleed these. But it is just a case of running that water pump. So you do need a diagnostic scanner to plug into the ODB2 port to trigger the water pump function. So I'll go through all of that as I do it, but that is probably what's going to stop most people doing this job themselves, unless you can borrow a scanner or got access to a scanner. Or the other option you can do is put 12 volt on the motor and power it directly. It is a 4-wire connector, I'll show you that in a minute, but that's the other option, is you could manually power that motor, because it is just a case of spinning that motor for 30 seconds to pump the water around, and eventually all the air will get back up to the reservoir tank, and that's how it's bled. So the first job is I'm going to remove the cap, and I will put that somewhere clean up there, and then let's lift it up and have a look underneath. So let's get this draining out. So as you can see, the original stuff is very green, and this is what the drain plug looks like. Don't know whether that's focusing. This is obviously going to take a very long time to drain, because that's not 4 litres in there. That's only about 1.5 litres. One other thing which I didn't mention, but it's pretty obvious really, but don't do this when the vehicle's hot. You don't want to scald yourself on this liquid. Just check the radiator and the hoses with your hands and make sure it's not hot when you do the job. So ideally do it in the morning when it's all cold, when the vehicle hasn't been ran. But yeah, use common sense, of course. So as I said, this vehicle's 5.5 years old or more now. We're coming up to 6 years old. It's done nearly 102,000 miles. This coolant is nice and clean with no debris in it, but of course that's what you'd expect. But it's really, the reason why you change this stuff is just so that antifreeze still has the right antifreeze properties, because depending on the stuff, it has a life of about 5 years. So that's really why we're changing it, just so it's still keeping the antifreeze properties and the rust inhibitors and all the other stuff that's in this chemical. So I'm now going to put the bleed screw back in. Let's just pull the camera back out there and fill it with water to do a flush through. I'm not sure whether this stage is really vital. The Hyundai instructions say do that, so I'm going to do that, but the system is so basic and so clean, whether you really need to do a flush through, I'm not sure that that's essential, but anyway, I'm going to do it. So I just measured how much came out, and it was dead on 1.6 litres, maybe 1.7 with the bit that was on the floor. So that's quite interesting. So it's got a 4.7 litre capacity with the models with the heat pump here. So that means only about 1/3 of the liquid has come out. So makes you wonder whether this 3-way valve is going to be holding an awful lot of liquid in the electric motor, and the bleeding process doesn't include operating that. There isn't a way of doing that. So the bleeding process is only to run the water pump, to run the water around the coolant around the system to get the air out. And I would imagine, unless it's all very hot, that motor 3-way valve isn't going to divert it round there. So this obviously isn't a full coolant change, it's a partial coolant change. So I guess you could start disconnecting some hoses down there. I'll have a look at that in a minute. But anyway, next step of the process, as per the official Hyundai workshop instructions, is to wash the bottle and fill it with clean water. You notice there I've put the torch down there. There is a little bit of liquid still in here, so it's not even fully draining out of here. And it is on a flat surface. But anyway, This bottle doesn't need washing on the inside, it's still nice and clean. I will give it a clean on the outside while it's here and the undercover is off, because any water can drain down. And then it's got to be filled with water and activate that water pump to flush the system round. So as to what water you should put in, a lot of people will just connect a hose up and flush it through with a hose. Ideally, if you really want to be anal about this, you should put distilled water in the system, but you're going to flush it straight out anyway. So even if you use bog standard tap water, there's not going to be much left in the system normally. However, with this draining procedure here, I've proved that we've still got 2/3 of the liquid in there, so you probably don't really want to be adding more tap water unless that 2/3 is locked off separately by the diverter, that three-way valve down there, and this flush isn't going to interact with that, and then it will be fine. In my case, I'm using softened water from the water softener, so it is nice clean softened water and doesn't have any limescale deposits or whatever. It's very soft water. So yeah, let's get on and do that flushing stage. So I will continue to measure the water that I put in and out, just because I find this interesting, and it's the first time I've done one of these jobs, so I just find it interesting to see how well these draining procedures work, and it's quite clear already this is only going to be a partial drain. Unless I start disconnecting hoses, which I'll look at, but it is very cold today. It's only about 0 degrees and all the hoses are quite stiff, so I can't sort of squeeze them to help with the bleeding, and I'm going to have to warm it all up a bit if I want to disconnect anything, because it's all very cold and stiff at the moment. But anyway, if you took it to a garage and they obviously followed their instructions, I suspect they're just going to drain what I've drained, top it back up, run the pump, bleed it, and that's it. So in reality, you're probably only going to get a 1/3 coolant change each time. So next step in these Hyundai workshop manual is to flush it through, and they say fill with water. Don't say distilled water, just water. So I've cleaned the bottle, just the outside, the inside was clean, but I got rid of all the dust. That's now filled with softened water, and I've put about 1.5 litres in there, which is about the same as what drained out, so not much at all. And next we've got to run the water pump. So I've got my ODB2 dongle plugged in there, got my diagnostic scanner. I'm using an Autel MaxiCheck MX808TS. TS is because it's got the tyre pressure system on it. And this has a hot function. Just brought this round to the engine bay where there's a little bit more light, and in here we have got a water pump somewhere. There it is, electronic water pump, electronic water pump control. Right, okay, and as you can see, that's now running the water pump, and I can hear it down there. So that's just circulating round, and actually that water has gone very green, so that has captured a lot more of the original. My phone battery went flat there, but anyway, I'm not sure how much was captured, but yeah, that's pumping the water around, and that has very much gone greener, so there was a lot more original coolant in the lines. But what you then do is stop the water pump, get back underneath, drain that liquid, and repeat this process until the liquid draining out is clear. So I put 2 litres of clean water in. I haven't got that much back out yet, but as you can see, it is very green, so that's not particularly diluted. So clearly there is a lot of trapped coolant to still come out. So this flushing process, I would imagine, has got to be done 4 or 5 times, I should think. Right, flush 2, and it is getting more diluted. However, flush 1, I put 2 litres of water in and only got 1.2 litres out. I've now put another 2 litres in. So I am sort of measuring this to check that I'm getting all the tap water out and I'm not just diluting the coolant that's in the system. Flush 2 was 2 litres in, 2 litres out. This is flush 3, and as you can see it is more diluted, but quite a few more flushes to go, I should think. So here we are, flush 4. Let's just operate the water pump. That's got clean water in at the moment, and if I operate the water pump, just add a bit more water in there. You can see that got quite green again, so still quite a bit of water, original coolant in the system. So yeah, quite a few flushes to go. I can now start to understand why Hyundai dealers charge so much for this job, because it is quite time consuming. That is if they do all these flushes, of course. So it's next day now. I actually flattened the 12-volt battery, so that's charged up, but I set up a light there so we can see underneath. So where's the torch as well? Let's get that on there. So what's clear with this Hyundai draining procedure is you're only draining about a third of the coolant out, so you're probably only draining the radiator. This is the pipe from the coolant bottle, and you're draining the coolant bottle, and then by doing a flush and putting water in and then running the water pump, which is up there, you're getting some more coolant out of the chiller and some of the pipe work, but you're only ever getting 2 litres out. It's only draining this, and you're only obviously removing 1/3 of the coolant, and therefore you're just diluting the rest of the coolant that's in the system. So you're actually making the system, making it worse. You're not improving it. So maybe that's the reason for the American schedule, that once you've changed the fluid in this system, you then do it every 20,000 miles, because you're only ever changing a third, and therefore you've got to have repeated changing to replace all of the coolant. And of course it's diluted each time, so you know, 3 1/3 changes isn't going to change the whole system. So anyway, this procedure is flawed. So I've tried removing hoses. I've taken hose off here of the bottom of the 3-way valve, this one off the bottom of the radiator, but no extra fluid is coming out. Right, so I've just turned around here. So there's obviously a lot of coolant in the electric motor, and there's the pipes there. I don't know whether you can see that, but you've got the black diverter valve there, and then just above it are 2 pipes that go into the top of the motor. Well, the water's never going to come out of the motor, because obviously it's going to be coming out via gravity. You know, gravity's going to be pulling out, and those hoses are at the top of the motor, so there's going to be a lot of water in there which is never going to come out. Also, this 3-way valve is going to be shut, so who knows whether that is open on the motor circuit or not. I suspect it's not. Then from there it goes up to the inverter, so all of that's full of water which you're not touching. So I think it's impossible to bleed. So what I'm going to do is start removing some more hoses. You'll see I've taken some clips off, and I'm going to remove every hose I can and see if I can get some water out of this system. I've also connected the airline up to the reservoir bottle and blown water through, but that didn't help push any more water out. But because I've done about 6 flushes now, I've obviously got a lot of fresh water in this coolant system, which I've also now got to get out before I start putting the new coolant in. Or I put the new coolant in, run the water pipe and flush a lot through, but that's going to be incredibly wasteful. So if you're still watching this video, you've probably decided already you're not going to want to entertain doing this job yourself, and I don't blame you. So it's not a difficult job, it's just not a thorough job. It's just not satisfactory. It's not a proper coolant change. But then if you book it into a Hyundai dealer, they aren't doing a proper coolant change either, so they're only going to probably do that. Well, they're going to be following those instructions, the Hyundai workshop instructions, so they're going to be doing exactly the same procedure, and the reality is they're probably only going to be changing 1/3 of the coolant anyway. So what I'm going to do now is I'm going to trace some of these hoses, probably take the battery out and the battery box so I can see down here a bit better, but I'm going to see what hoses I can remove and see if I can get any more water out. I have a feeling though it's going to be very difficult because all these hoses go up to the top of the motor stack, and obviously gravity is keeping all that water down in there. So I will try to put a hose air pressure on there and see if I can blow it out, but I have a feeling it's going to be difficult to get any more water out of this system. So it's probably going to be quite difficult to film what I'm going to do next, so I'm just going to crack on and see what I can find. I'm going to draw out the system and work out what all the hoses do and where they go and what that three-way valve is doing, and then blow out the water that I can of the systems that I can access, or you know, the cavities and chambers that I can access. So I'll probably just crack on with that and not stop to film it, and then do a summary at the end of what I did to achieve maximum draining, and then I'll come back to you when I've done that, and then we can start filling this system back up. So I've removed the motor plastic cover there so you can see some of these hoses, and I've traced all the hoses and drawn a schematic of how the coolant system works, and it does tie in with the Hyundai drawing. So basically you've got your coolant bottle here, and there are 3 hoses from it. So the top hose is the return hose, and that goes straight to the bottom of the radiator. So let's concentrate on the water flow. So you've got this hose here, the bottom hose goes straight down to the water pump, and I've drawn this diagram in the correct level. So you know, electric motor's at the bottom, radiator's at the bottom, the bottle is at the top. So it goes into the water pump, and the water pump then sends it into the electronic control unit, and that's actually the top unit. So the water pump is sending the water up here, so it's coming straight out the bottle, down to the pump, straight into the inlet port here, around here and out of here. So it's coming out of here, then it's then dropping into the motor, and that drops straight down and goes into the top of the electric motor, straight back out of the motor into the bottom of the three-way valve. And then at the three-way valve, I'm assuming it can either send it this way or that way. So let's do this way first. So this way is then coming up here to that bottom hose there into the chiller, and then it's coming out of the chiller straight into the bottom of the coolant bottle, which you can see there. If it's going to go the other way, it then goes into the onboard charger, which is this second unit down in the motor stack. I'm not sure whether this torch is helping you, actually, it's difficult to tell. If I can put that somewhere where we're going to show some light on it. So it's then coming into the onboard charger, which is this hose here, and it's then going in there, and then it's coming out here, and then it's going into the top of the radiator, which I've shown here, there, and then it's going through the radiator, it's cooling the liquid, and it's going straight back up here into the bottle. So it's a relatively simple system. The problem is it's all up high, so I'm going to, with this cover off, you can get to all these hoses, so I'll disconnect these hoses and blow a line through and see if I can get any water out. But I suppose it depends on which position this three-way valve is. So anyway, this water pump was working, so it's pumping through the top unit and the motor and back to there, and I was getting water out the radiator, so it looks like it's going through the onboard charger and through the rad. So it is draining all of the motor stack, so it is draining the whole system. But what's clearly happening is a lot of water is getting caught in here, and while it's flushing through when I'm running the water pump, I'm never actually getting the water out the system. So if you could add any more to this, do comment below. I find this stuff quite interesting, but clearly, unless you're going to put any pressure on there and blow all the water out, you're never going to get this water out, I don't think. But anyway, if you can add any more to it, then do let me know. So what I've done is remove the three-way valve and its three hoses. So we've got the hose here coming out of the motor. I'm not sure whether you can see that there. Then you've got the other hose here coming into the motor. So that's coming up from the controller at the top, from the inverter. And then where are we? This one is coming from the chiller, so I know that one's empty. This one is coming from the onboard charger. So I should be able to get to the hoses at the top now and blow the water through all of these components, and it's going to come out of these two hoses. That's the plan anyway. And this is the three-way valve. One hose there, 2, 3, and it sits this way up. So this hose was very difficult to remove to get the clamp off, so that's why I took it out, because it was easier to take the other two hoses off and then take this out and then wiggle this off the hose, just because this is all plastic and it's cold, and plastic gets brittle when it's cold, and I didn't want to break that. That top bolt is rather awkward to get out, but it's a much easier undoing bolts than it is messing around trying to get hoses off, so it was easier just to whip this out completely. I could then also drain it of water, and I know there's no other restrictions in the system then. So finally, it looks like I've got all the water out the system. I've disconnected the hoses here from the inverter and blown air through and got the water out. I've disconnected the hoses here from the onboard charger, again blown it through. This hose it goes to the top of the radiator, so I've blown air through here, and that's got more water out the radiator. Loads came out the bottle as well. I've disconnected this hose from the bottom of the bottle, blown that through, cap on, cap off, and sort of blown air through every pipe that I can. So hopefully now all the water is out of the inverter, the charger and the motor below, also the chiller. So I can put it all back together now and refill it. So I've now put all the hoses back on the motor, inverter and charging unit there on the top of the rad, back on the bottle. So I can now start filling it up. So Hyundai's workshop instructions for this is fill the bottle up slowly, squeezing the hoses as well to help to bleed it, and then when you've got as much coolant as you can in, switch on that water pump there with the scanner, and that circulates it around the system, and you keep doing that until you don't see any more bubbles there, which is great. That gets most of the system bled. But looking at my drawing I made up of the system, it's quite clear that the onboard charger is still going to have a huge airlock in it, because this three-way valve probably is stopping water going in the onboard charger, because it's allowing it instead to go through the motor and your inverter at the top. So it makes sense to actually plug the vehicle in on AC charging, get it to charge. That, I'm assuming, will then activate this three-way valve, which will then send water through the onboard charger. The water pump will be working as well when it's charging, because that always does, and that will then bleed that circuit. The instructions don't tell you to do that, but it obviously makes sense that that needs to be done as well. So that's what I'm going to do, but it is sort of getting dark now, so I'm going to fill it up, and I'll probably come back to this in the morning now. So I've got to try to get 4.7 litres of coolant back into this system. So that'd be interesting to see whether I can do that. Just squeeze these hoses. Not that I can really squeeze them that hard because it is so cold today. It's going to be very difficult to massage these to get any air through. But yeah, only got about 1.6 litres in so far. So once that water pump activates and starts pushing it around the system, then that's just going to obviously get loads and loads of air out. So I'll operate the water pump. Quickly get some more coolant in there. I'm going to have to cancel that water pump and get another bottle. So I'll just activate the water pump again. A little bit more liquid in. And then wait for that to stop bubbling. So that's been 4 litres of water gone back in there, well, sorry, coolant. So just shows I did get it all out. So we're looking at a 0.7 of a litres left in the system, and I suspect that's going to be that charging circuit, the onboard charger. So let that run, and then I'll plug it in, get it charging, which will open that 3-way valve and get that system going, top it back up, and then probably take it for a run as well, because you're going to have to check these things and also check all of those hoses that I've disconnected, just make sure nothing is leaking. The time that you run that water pump for to do a proper bleed, my scanner is saying run it for 10 minutes. The Hyundai workshop instructions aren't clear. It says the water pump actuation must be completed in 10 minutes, but that doesn't mean the same that you run it for 10 minutes. But anyway, that's what all it says. So you need to be running this for 10 minutes just to make sure that that coolant is bubble free. And then the final thing the instruction says is what I've already said: you need to drive it, and it says check it after 2 to 3 days. So my conclusion of this job: if you use a Hyundai dealership, they're going to just follow their workshop instructions step by step. And what it looks like, as I've shown, is you're only going to be able to change 50% of the coolant or so, or maybe less, a third of it. And if you then do the flushing sequence, you're actually diluting then the coolant that's stuck inside your motor stack. So actually it's making it worse. If you just drain the coolant and put some new straight back in, that's going to blend with what's there, and you're still going to have the proper antifreeze level. But if you do this flushing, you're actually making it worse, because you're just adding water, and even worse if you just put tap water in it. So yeah, the instructions clearly don't do a proper job. If you do what I've done and taken the hoses off and blow it all through, I was using an airline. I also put my lips around a hose and blow, and that does it as well, but the airline really blew it all out. Then great, yes, you're going to get all the coolant out, and I've managed to get all the coolant back in, so it's a proper job. But I don't think your average Hyundai dealership is going to do that, because they're going to follow the instructions they provided. So there we go. So maybe that's why you have to do those 20,000 mile service intervals afterwards, because slowly you're adding more antifreeze, and over the years you will get that antifreeze level back up. So that would explain why from the factory it has a 5-year interval. Once it's been done, it then has a 20,000 mile interval. So yeah, and as to whether you could do this job yourself, the fact that you've got to operate that water pump down there probably means that most people aren't going to be able to do this job themselves. You really need a scanner, and one that can talk to the water pump, or you're going to have to take the connector off, There's 4 wires on that connector. Work out which ones are 12 volt and manually power that motor, which you could do, but it's awkward. It's a little bit awkward to get to. You'd have to do it from the bottom. The other thing I would say is you don't need to actually do all this underneath the car. You can access the radiator drain plug down there. Just be a bit careful that the car's not on and the fan would operate. But yeah, you could undo that plug and just let it drain over the tray, and it would all fall out to the ground. So the only thing that is awkward if you want to do this yourself is just operating that water pump. But then what I've shown here, if you can do that, you're probably going to do a better job than the main dealer is going to do. So this is stopped pumping, and I've got 4 litres and whatever I've taken out of here. So I'm only, I don't know, 0.3 of a litre off the target capacity now. So I think doing that charge and just allowing that other bit of circuit to open, and I'll take it for a drive tomorrow, I think that will do. So I've managed to, well, when I've done that, I would have managed to do 100% flush, which is obviously quite likely to be a lot more than what the dealerships are going to do. Anyway, that's it for this video. If you found this useful, please do click the thumbs up button on YouTube. That really does help. It allows other people to find the channel. Do comment as well. Let me know where I've gone wrong, if you think I'm doing something wrong here. And I'll see you on the next video. One final note, I'm got this charging on a granny cable, so it's only charging at 10 amp, and the water pump isn't running, so that 3-way valve hasn't moved either. But it's only about 2 degrees here, so it could be that this onboard charger is still too cold and it's not going to change that 3-way valve or turn the water pump on until it needs to, until it's warm enough. So yeah, charging on a granny cable might not do the trick, but I'm sure if I drove this and DC rapid charged it, or maybe just on the 7 kilowatt wall charger, it will be enough to warm it all up and send the coolant round the last bit of the system. Any other thing I just wanted to mention, if you've taken your vehicle in to a Hyundai dealership and they've done this and charged you for 3 bottles of battery coolant, this is a 2 litre bottle and the system takes 4.6 to 4.7 litres. So just make sure you get your half a bottle of coolant back that you paid for, because if they haven't done a charge and done a drive, you could find after a few days that the coolant level is going to drop, and you don't want to be going back to the garage and paying 26 quid or whatever this was. I think this was £18 plus VAT for a bottle. You don't want to be buying another whole bottle just for a top up when the workshop's clearly got the rest of your liquid they've invoiced for you for anyway. So just bear that one in mind. Okay, see ya.